Welcome to Buildings and Beyond,
the podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
I'm Robb Aldrich.
And I'm Kelly Westby.
In this episode, I spoke with Andrew Linn, who is an architect based in Washington, D.C. We talked about sustainable materials and products he uses quite a bit. And we talked specifically about the Grass House project, which is actually his office in Washington. As you'll hear, Andrew is really a believer in many of the products he uses, which is very cool. We often try to avoid too much discussion of specific products on this podcast, but that is not the case in this episode. A quick disclaimer, this isn't necessarily an endorsement by Stephen Winter Associates. These are Andrew's opinions, but I really enjoyed talking with him and I learned quite a bit. We'll provide some links in the show notes for folks who want to dig deeper. I also wanted to mention a couple podcasts we had, a two-parter we had back in the summer of 2019, where we interviewed Charlie Stevenson. We talked more in depth about sustainable materials, so if that's an interest, you might want to check those out. Here's my conversation with Andrew.
I have always wanted to be an architect. I grew up wanting to be an architect, and I worked for some of the best offices I could imagine working for when I was in school. And when I left school, I realized that even those offices were hampered by the material palettes that they were able to work with. And so my college best friend and I set out to find a healthy building material palette. So we moved to DC, where we felt like there was already an appreciation for the landscape and for the materials that come from the landscape. There was also, and is in DC, an awareness of and attention to code and regulations and designing for those most in need. So we felt like DC was the place to build our practice. So we moved to DC, founded Build Us, and began looking at the materials that were available to us, although not always the most popular, that were the healthiest for the environment and for the users of the buildings.
And I just realized the URL, your website, the URL is great. It's bld.us. And you say Build Us? That's how you say it?
Yep, like a proper Roman name.
But it's the BLD is the initials of your firm. Isn't that right?
We began as Becker, Linn Design.
Okay.
My name is Andrew Linn, and my partner is Jack Becker. So we began as Becker, Linn Design, but we've begun just referring to ourselves as Build Us, both in website and in name, because we like the ethos that it promotes.
All right, cool.
Yeah.
Cool.
We're about building community. We're about building using American domestically sourced products. So Build Us is a really nice idea to strive for.
And it's a very easy to remember URL. That's pretty cool.
Exactly.
So when we were talking about doing this podcast a week or two ago, you used a term that I don't know that I'd ever heard before, which was farm to shelter. Farm to table. This is farm to shelter. Have I missed that? Is that something that you coined? Is that something you've been thinking about for a while?
I hope I haven't coined it, but I haven't heard it much, so it wouldn't surprise me if that's the case. Half of the TV that I find that's available has something to do with cooking, and even if it's not a cooking show, they find a way to bring it in. And people are very interested in where their food is coming from, how it's getting to them, who's taking it out of the ground, and how they're being compensated for taking it out of the ground. That same attention and awareness has gone into the clothing that we drape around ourselves, and it only seems logical that that type of awareness would also extend into the built environment. So There are different ways of tracking the health of a building, like the Living Building Challenge and like the rating systems. But they're very challenging. We've tried to work within those requirements, and in DC middle class housing, it's really not feasible without subsidy of some sort. So we've been looking for a farm to shelter material palette that is affordable to the middle class, that doesn't require a whole bunch of soft costs sunk into applying for different ratings and different certification systems. And we're just looking to bring affordable, healthy housing to the people that need it and who are reliant on Home Depot and Lowe's. And nothing against Home Depot and Lowe's. They are getting with the program almost quicker than many of our clients.
Yeah, I thought that was it was kind of interesting for me to hear that term, just using local sustainable materials, farm to shelter. We've all heard farm to table. It was a pretty clever term, I thought. So, I guess the project that we started talking with you about, and Stephen Winter Associates worked with you a little bit on it, is called Grass House, and it is it your office? Is it your primary workspace, studio space?
Yes, it is.
Okay, and it's an outbuilding. Well, actually, yeah. Could you describe what it is, where it is?
Yeah, so the Grass House is basically a compostable accessory structure built behind an 1892 Queen Anne Victorian house at the foot of the Frederick Douglass House in the Anacostia Historic District. So this is east of the Anacostia River. It's the only historic district in Ward 7 and 8 of DC, even though there are a few others that deserve to be historic districts. But we that's where we work from. We do a lot of work there. It is a place that has a pretty diverse, eclectic set of styles within its historic district, but that's within a time span of about the 1880s to the 1910s. So we're working within that vernacular and trying to design and build a building that is as healthy as possible. We ended up with a LEED Platinum rating on it, and is as sort of affordable, or at least speaks to different affordable moves, so that we could use it as a showcase and bring in different potential clients and different people who are interested in it, different neighbors, so that they could see possibilities. So we have a fun stair, we have a fun window detail, we have a fun bathroom countertop detail, and we usually tell our clients that they could pick one or two of those details to really play with in their house. But in addition, we're trying to showcase as many different healthy building materials and natural finishes as possible.
Yeah, so folks can go to bld.us, and there are pictures there, which is pretty cool. The first thing I noticed when I looked at the pictures was this is a very small building.
Mm-hmm.
Okay, I think was it like a 250 square foot footprint or something like that?
Correct, and for that
Okay.
reason, we went down and we dug out a basement, which in general we're not typically fond of, but we wanted to maximize the square footage that we were able to have, but we wanted to keep the overall massing as small as we could.
So you used a term a couple minutes ago. I think you said it's a compostable structure, which I understand, but does that term have great optics, or does that? I mean, the first thought is, it's going to rot quickly. Do you run into resistance with that phrasing? Does it test well?
I mean, the people that I'm quote unquote testing it with are very into the idea.
All right.
Because we quickly explain that the techniques that you use to build the building require attention to detail, and you pull the wood or compostable material up off the ground a little bit, and you protect it with big overhanging eaves, and use a nice breathable rain screen system so that the whole building can breathe. When you approach a building trying to find the places where it will fail, which are almost always related to water or moisture in some way, when you approach the design with that as your priority, the fact that the materials that you produce it with are compostable, it isn't an issue. So at the Grass House, we have a slate and copper roof. You're not going to find a more durable roof than ours. We have big overhanging eaves. We have a breathable exterior cladding system. We have a concrete base that comes up 2 and sometimes 3 feet up off the ground, so that all of our bamboo and wood framing system is away from rain, and we collect all the water that falls off of our roof, and we harvest it in a cistern. So when you have control over the water, or at least when you have respect for the water that is trying to degrade your building, you're able to make the building out of healthier materials.
So you mentioned bamboo, and that's where the name Grass House comes from, I believe. Maybe I assumed that, but I believe that's where that came from.
You're right.
Can you talk about the wall system a little bit?
Yes, I'd love to. I love Bamcor. I'm one of their biggest fans. Bamcor is essentially the mass grass to mass timber. So it is a lighter weight version of the same principles that are being applied in mass timber. And as many of us have come to realize, mass timber doesn't have great implications for the single family and low-rise residential markets, but Bamcor does. And that's exactly where Bamcor is at its best. So Bamcor has been refining this panel system, and what the panels allow us to do is build without studs. And that gives us continuous insulation cavities, which gives us incredibly high-performing wall systems that allow us to contain either the hot or the cold air that we're creating. So we're able to input very little energy into heating or cooling a Bamcor house. You're able to reach passive standards almost effortlessly because you're removing all of the standard thermal bridges, which is what exterior insulation envelopes attempt to do and do. But Bamcor does it in a more integral, more high-performing way.
And this is, I don't have any firsthand experience with this product, but it's a panelized approach. So like all the walls come on a truck or a pallet or a couple pallets, and then you all cut in the right dimensions and labeled, and it's piece it together on site pretty quickly, I imagine.
Very quickly, and a real benefit of Bamcor over other systems like SIP systems or pre-manufactured systems is that these are panels that you and I could lift, and I don't know what you look like, and I know that you and I could lift them because it's essentially a piece of drywall. So you're able to remove drywall, you're able to remove studs, you're able to remove OSB sheathing, and you have these packets of pre-cut wall panel delivered to the site. You pop them off the truck and up onto the site, almost like an IKEA structure. They used to have you screw them in, and now you're just nailing them in. So very simple, and very simple to take apart, someday in the future. These panels are unbelievably durable. They're made from bamboo, which is in some cases as strong as different types of metal, stronger than different types of metal, and that allows for the panels to have shear strength to them. They're bulletproof. They perform extremely well in hurricanes. The makeup of these walls and these wall sections allows you to have thinner or larger wall cavities. So these walls are just as high performing and cost saving as they are in Florida as they are in Vermont. So
We can put some links in the show notes because, I mean, I talked to you, you described the system a little bit, but I didn't get a full picture until I looked at some pictures. And as the podcast is only audio, we can certainly link to it because it was pretty cool. I didn't get a full picture of how all the pieces went together until I went to the website, and it seemed like a lot less material because my understanding is they are trying to grow bamboo domestically, but they are not yet. So a lot of the material gets shipped a long way, but there's much less material. It looks like. Is that a big piece that goes into it being a carbon winner?
it's a huge piece. There's less material waste, and bamboo is the best carbon sequestering organic material that exists. So the more bamboo we can use, the better. Bamboo, unlike wood, retains the carbon that it sequesters even while it's being harvested because it gets clipped like grass, not mowed, not clear cut, but clipped. And so a clean bamboo grove is healthier, and taking out culms that are ready to be harvested makes for a clean bamboo grove. So the more bamboo we can use, the more bamboo we can plant and store in the built environment, the more carbon we're going to be able to sequester. So even though right now that BAMCOR is bringing bamboo in from places like Central America and South America, which are still relatively close, given that we get Doug fir from Washington State or Oregon. They're working on creating a domestic supply of bamboo, but there's already so much bamboo around the world that we just need to find more ways to use it in the built environment.
And insulation, you can use any insulation with this panel system, but you went with wool, which again, I don't have any firsthand experience with. Not mineral wool, but like sheep's wool. Is this the first time you'd used it, or is this one of your kind of go-to materials?
It has become a go-to material since working on the grass house because we love working with it so much. It doesn't outperform other materials more than the other healthy materials that we're looking at. So BAMCOR is exceptional compared to wood stud framing. Wool is exceptional compared to fiberglass. But being able to touch wool, it feels so good. It feels good to stuff it in the house. It feels good to know that you can breathe it. The sheep's wool absorbs VOCs that are in the air but does not produce any. It expands over time. It wants to return to the state that it was in when it was on the sheep. So those cavities, are going to be full, and they're not going to have any sagging spaces, which is especially important.
It expands over time?
It expands over time. Every piece of wool that comes off of a sheep, it grows in a certain way on that sheep, and then we pack it into a bag and we send it to a construction site, and then we pack it into a wall cavity, and it wants to return to the shape that it was in when it was on the sheep.
Okay, kind of elastic.
Yeah.
A little bit of elastic. Because I certainly have wool clothes that do not expand over time. They do the opposite, but it's a different thing we're talking about.
Yeah, that wool's been processed, and it's been cleaned in a different way, and it's been strung out into yarn, and then it's been sewn into a textile or a fabric. Here it's being cleaned and treated with an a pesticide in as simple and sort of light of a way as possible, almost like when you're making a pastry and you're trying to handle the dough as little as possible so that you can keep the air in the dough. That's the way that they treat this wool.
And it seems, here again, I don't have any experience with it, but it seems that raising livestock for an insulation material would be pretty carbon intensive. But I assume you or somebody has crunched the numbers and found otherwise. Is that accurate?
That's accurate when you think that the alternatives are recycled denim that has already gone through some pretty awful, pieces of life, or not recycled and just denim, which will sag in the wall cavities. Fiberglass is not produced in a great way. Mineral wool, which is invaluable in cities in certain applications, has a pretty bad reputation in the communities that it's produced in. So it's not like there are great alternatives out there. There are certainly nice ways of raising sheep that are good to the sheep, good to the ground, and in some areas that we're working in, people are advocating for livestock rather than maintenance of grounds, large-scale grounds using lawnmowers and things like that. So, there are trade-offs, but the way that the wool performs is exceptional. The material that I could see that could enhance the use of wool would be mycelium, and I know that Ecovative is working on and has always thought about different ways that they could use their mycelium product, which is the roots of mushrooms, in the built environment, because then we could really be growing our insulation. But sheep's wool is an incredible performer. There's an abundance of it right now. A lot of the wool that's produced is not acceptable to textile manufacturers, and there isn't really a use for it. There isn't a market for secondhand or third-hand wool in the U.S. yet, but if people start asking for it, then I think it would be a great solution to stuff that into wall cavities, BAM-core wall cavities. Yeah.
Cool. So in the roof, you had to go more conventional, I think you said. You had to use foam, is that right?
We are insulating our roof with foam, yes, and that's so that we can have a pretty small roof cavity. We had a 20-foot height maximum because we're an alley house, and we wanted to fit 2 stories in. So it's a relatively tight insulated cavity, but it allowed us, by staying tight there, it allowed us to vent and insulate on the top above the decking, but below the actual roofing. So we're roofing with slate, and that sits on top of a black locust sort of raft of eaves and timber members that hold pieces of exterior insulation, and that sits on top of this unvented roof cavity.
So, I mean, is there any reason other than kind of R value per inch, is there any reason you could not use wool in the roof assembly?
No, wool would be exceptional, and they're making wool in bats. They're making wool as loose fill, so it can be sprayed in, blown in, which would be a perfect application for a roof, for an attic. Wool, I would love to only use wool and cork and mycelium as my insulation materials for the rest of my career, and I think it's amazing that we could be, having house stuffings with our clients and their families with sheep's wool in the same way that communities used to do roof raisings or things like that, just so that they know that what used to be the toxic, poisonous phase of the construction period, when you're, stuffing your walls with fiberglass or foam, is now a thing that the whole family can participate in because it's so healthy.
We'll see if we get any comments about calling fiberglass toxic.
Well, it is not something that anyone wants to breathe in, that's for sure. And the fact that pregnant women aren't supposed to be around construction sites during certain phases, like we would like for our compostable houses to be able to be built with pregnant women as their GCs. It's unacceptable for our buildings to be poisonous for a certain phase and to assume that they're going to just air out. That's how we feel about that.
So talk about the siding a little bit. And again, I encourage people to go to bld.us to take a look at some pictures. The siding is pretty cool, and the whole siding assembly, I think.
Thanks. The cladding is produced by Reson Timber Company. They are a very cool Pennsylvania-based company that's doing research into different methods of finishing wood. Sometimes the charred wood using the Japanese technique. Sometimes they're mixing that with certain stains and oils and finishes. They're using a lot of wire brushing, and they have these really cool assembly lines that are sort of pizza oven style. but they, char in 2 different temperatures and wire brush in 2 and stain in 1. And they're able to get these pretty nice finishes. So we have a very simple product from them. It's Atlantic cedar. We worked with them to source Atlantic white cedar, which they hadn't done before. It was considered sort of too shabby before, and now it seems like there's a demand on their website for Atlantic cedar because it's more local than red cedar or even the cypress that comes from the southeast. So we have a really nice black cedar siding, and that is sitting on furring strips that are at diagonals because our cladding is at verticals. So we wanted to pull our cladding off of the main building structure using the furring strips, and those diagonal furring strips are crossing at our corners. So sort of like how stone is coined, we're coining our furring strips at the corner.
Cool. And yeah, you used a lot of other wood for local materials, I think mainly wood, for interior finishes. And again, the pictures, I think there was a bench detail that looked pretty cool, and the stairway, like you mentioned, was a very cool design element. Did this come, how much of it was you deliberately going out to find something to do what you wanted to do, and how much of it was, hey, I have a great source for black locust or willow or walnut, or how did those pieces come together?
So we're trying to put together the ideal healthy building palette for the Mid-Atlantic, and certain of these materials just perform better in certain applications than others. And that's the case whether it's bamboo or willow or wood, and the different subspecies of each of those. So willow is great for interior guardrails and screens, and so that's why we wanted to use willow for our 3 different interior guardrails, and we took different strategies as to how those were designed and built so that we could learn ourselves and so that we could show clients what's possible. We knew that on our exterior we wanted to use black locust because it is very local, very abundant wood that performs just as well, if not better, than mahogany and ipe and all these other tropical species. So if we're going to be importing bamboo, we want to do it for the right reasons. If we don't need to import wood because we have this other tree that's everywhere and just not used that much, we're going to use that. So all of our exterior wood, all the big members in the roof and the bench, and the sort of pergola over the front door, that's all black locust, and we loved working with it. It's kind of a fussy wood. It moves and it turns a little bit, but if you can sort of brace it with itself, so we're kind of making little weaves out of it, then it locks into place, and it wears over time really well. It's not impacted by water, and we expect it to be just fine for 50 years or so. On the interior, we're finding uses for a few different trees that we knew we needed to take down in the neighborhood. So 7 blocks away from the grass house, there were a few trees hanging over a commercially rented parking lot where food trucks were parked, and those trees were only being held up by some grapevines that were like huge and holding them back. And so we felled those trees. One was a mulberry and one was a walnut. And we used the mulberry for all of our handrails and on the stairs and a few other interior details. And we used the walnut for our beautiful stair slabs. The walnut was basically purple. Wow. It was great. And we used one of its big branches as our handrail up on the second floor. And we used some leftover wood for the bathroom countertop and the toilet seat. And we really... We used it like a buffalo.
Cool.
Yeah.
So I'm just thinking about the panelization for the walls for the main systems in the home, and I think in talking with you earlier, panelization is a pretty strong interest. Kind of on the other end of the spectrum, though, it's just kind of this custom details using local trees, which is kind of it's kind of entirely different than standardization and panelization, but they seem pretty complementary. Can you talk about your goals? Just how far you want to panelize versus customize?
Yes, and it's a great question. And it's you can kind of think of it like the Tesla Cybertruck, which is rolling off the factory assembly line with as few pieces as possible, versus a really high-end sports car that has hand-done details, handmade details. Um, we don't we don't, and Bamcor doesn't want to take anyone out of business, or take laborers off the site. I should say we don't want to remove work and remove workers. We want to be able to build more affordable housing because there's a shortage of affordable housing in a healthier way. And so if we can redirect the labors of the workers away from places like painting walls, and we know that painters have higher rates of cancer because they're interacting with paint all day long. If we can take them away from painting because we're charring and finding other ways to finish our interior wood panels instead of drywall, then we can redirect them and have them working on some of these nice handcrafted details using wood, and we can have more of a carpenter-like industry like we used to have 100 years ago, when chestnuts were popular and when houses were hand-built and when craftsmanship was appreciated by people. And you can see it in the food industry that craftsmanship and quality and materiality has become very important, so much so that these companies like McDonald's and the big fast food chains are having to become their version of farm to table. So we're hoping that construction can tend away from the materials that we are left with after World War II, and tend towards the materials that make sense for the health of the inhabitants and the health of the planet.
So if we talk again in 5 or 10 years, what do you think we'll be talking about? It's like what systems here do you think will become standardized? What new do you think we'll start seeing more and more of down the pipe a few years?
Yeah. So I think that Bamcor is ideally suited for producing housing in large quantity. So, ideally it's not subdivision tracts. Ideally it's denser housing than that, so that we're not having to eat up the entire landscape. But if it is subdivision tracts, if a developer is going to do that, then I hope that they're building with Bamcor, not because they want to be green, but because they know that they can market the energy savings to their customers. And that will allow that and an acceptance in cities of Bamcor in the low-rise residential sector, which I think will come more naturally. I hope will lead to Bamcor having a real impact and Bamboo having a real impact on the framing systems of low-rise residential all across the country. I think sheep's wool is going to be sold on the shelves of one of these big hardware stores in the next 5 years, if not probably much sooner than that. I think cork cladding has exceptional potential. Right now there's a need to put cork into use across the world because there's all these cork plantations around the Mediterranean that are no longer supplying wine bottles with cork because they've turned to metal. And cork is a fantastic exterior insulation material, which is now required by code, and can double as a cladding system. So bark is another great exterior cladding material, but bark is a little more boutique, a little less performative in that it's not insulating, and cork is just exceptional at it. So I hope that the popularity of cork as an insulative material, as a cladding material, as a flooring material will start to come back, because it was very popular in the U.S. before World War II, and before the foam industries were required by the needs of of a war. So yeah, and if those three major products, bamboo, wool, and cork, are finding their way into more intelligent uses of wood, then I think we have a really bright material palette for everyone to get their hands on.
Fantastic. Well, thank you. This has been a great conversation. Thanks for taking some time to talk.
Of course. Thanks for having me.
Thank you for listening, and thanks to Andrew. Check out the show notes for links to some of the info we talked about. Buildings and Beyond is produced by Stephen Winter Associates. We're focused on making buildings better, more sustainable, more healthy. Also accessibility, efficiency, resiliency, comfort. Check us out at swinter.com. That is swinter.com. Swinter.com/podcast is where the show notes live. And check out our careers page if you're looking for opportunities. We have positions posted for all of our offices: Boston, Connecticut, Manhattan, and Washington, D.C. Thanks again to Andrew, and thanks to the podcast team here at SWA: Jade Alvarez, Dylan Martello, Heather Breslin, Alex Mirable, Kelly Westby, and I'm Robb Aldrich. Thanks.